Hello everyone and welcome back to Capacity TV here on the sunny networking terrace at Datacloud Global Congress 2026. I'm Amber Jackson and I'm delighted to be joined by Eric Topham, CEO and co-founder of Octopipe. Eric, it's lovely to see you. Thanks so much.
Fantastic to be here. What a great location.
I'll say, absolutely. The sun is shining today, which is fantastic. I'll just dive right in. Be really curious to know what your hot take is on where liquid cooling is headed. And I guess, does the industry fully grasp what this shift means from an operations perspective?
Sure, yeah. Look, so it's an interesting question. As a machine learning guy, fundamentally, I am kind of coming into this with sort of a somewhat of an outsider's perspective. I think what I see that's sort of super interesting is not so much necessarily related to liquid cooling and its various, variants in and of itself, but actually kind of the context within which these liquid cooling technologies are being operated. I think there's a huge amount of rather kind of absolutionist hype that's written about liquid cooling. Everything's going to be liquid, or everything's, not going to be liquid. Mostly, obviously, everyone's saying everything is going to move to kind of liquid cooling. And I think that just doesn't actually really reflect the reality of what we're seeing when we go into customers. So, I would say that there are some specialized sites that have been developed where the intention is for the cooling system to be primarily liquid cooling based. But in fact, in the majority of sites that we're engaged with where there is some intention of installing liquid cooling, typically what we're actually seeing is a sort of a hybrid architecture that's being installed. And so I think this kind of raises a couple of interesting points. I mean, the first is I think that there doesn't seem to me to be a large amount of sort of institutional knowledge or memory about how to actually operate liquid cooling systems, and even less how to operate them in a sort of an optimal fashion. And then coupled into that, the fact that then there's an even bigger question of, well, how do we do that when we have these hybrid systems that are being operated either where we've got air and liquid cooling in different parts of the site, or where in fact we might even have those two things combined into the same hall. So I think there's already a question mark for operators about how do I just operate this? And then the second piece is that then you've got people like ourselves that are coming along and saying sort of in general the paradigm of how we manage cooling systems, not just liquid ones, sort of needs to change, where we need to move away from this kind of traditional static way of managing things to something that's much more dynamic. So operators kind of have a sort of a double headache about, okay, well, I've got this new cooling technology from the hardware side that's coming in, this whole new piece about how do I manage the fluids and, the quality of the fluids, the fluid management and the hardware itself, new types of failure modes. But then I'm also being asked to kind of operate it in this kind of new sort of fashion. So I think liquid cooling has a long way to go right now in terms of actually kind of getting from conceptual promise to sort of operational reality, if that makes sense. Yeah.
Absolutely. And I think one of the other things that liquid cooling perhaps promises is efficiency gains, but it also introduces a whole new layer of physical complexity to manage. So I guess from Octopipe's perspective, is the industry ready for that? Or are we getting too ahead of ourselves?
So I suppose that's kind of where I'm going, right? So I think from an engineering standpoint, liquid cooling presents a very elegant solution to more efficient cooling for high density workloads. Of course, I think we're all very aware of that. I think that too much is written from a very kind of sort of binary point of view, in the sense that yes, liquid cooling has the potential, the right architectures to remove 95% of the heat, but on a 130 kilowatt rack, you're still then left with about 5% of that, which is about 7 kilowatts, which needs removing, and that is going to be also effectively removed by air, right? And there are kind of restrictions in the architecture of the racks and so forth that we need to leave airflow within there. So firstly, I think that it isn't the case, as we often read, that sort of everything will be liquid cooling. Inevitably there is a role for air mixed into that. Then yes, absolutely, the operational complexity is there, because typically these systems, while there are sites that are being built obviously from scratch with liquid cooling as the intended primary solution, the retrofit market is huge, and so these systems are being mixed in, and so in that mix, we don't have this kind of institutional memory about it. So for us, that presents a sort of an opportunity because, frankly, because the industry sort of isn't ready for it, it allows systems like the one that we've built at Octopipe to kind of step in and say, well, actually, we have been able to model those systems. We have the models, the machine learning, the AI that can handle that for you, and not just deliver some, improved efficiencies, but also take away some of the operational headache for you at the same time. And I think that's kind of a real gap at the moment, that people are still trying to really figure out how to do things, and that's somewhere where we can step in and really help.
Let's talk about Octopipe a little bit more. But I mean, by your own admission, you've said you're a small tech startup, and yet you're partnering with, an industry giant, I suppose, ABB. Can you kind of share how that partnership came about, and I guess what does it say about the direction of the industry? Like where is that moving right now?
Sure. So I think the first thing to understand is that Octopipe is a deep tech company. We've been going for some time. At the core of who we are and what we do, we have been developing some beyond the state of the art machine learning that we think of as sort of being built into a physical AI paradigm. We have a whole thing about somewhat rejecting the LLM and transformer-based architectures for the sort of physical environmental modeling, control response modeling that we think we need when we're modeling and operating critical physical infrastructure. And so that's kind of where we've come from. We've also come from a world of sort of understanding that AI systems, particularly in critical infrastructure, need to be trustworthy. And so we've built some very secure, distributed machine learning that allows us to kind of deploy into this sort of infrastructure and satisfy some of those security requirements. So that's where we've come from. With ABB, we actually met them now, I think at least 2 years, I think it was about 2 years ago. There's a conference, a deep tech one runs in Paris called Hello Tomorrow. We met some of the partner team there, and we originally engaged with them over provisioning them with some technology that we had developed and we still use, that is based around something called federated machine learning, which is where we have a totally distributed form of learning machine learning models where we can deploy them into sites, onto assets, train models locally, and then return secured encrypted parameters. So that's how we kind of got involved, and then we had sort of taken the decision to strategically kind of focus ourselves specifically into the data center market, very specifically onto the cooling efficiency use case. And we kind of sort of politely let them know that that's what we were going to do. And they had been a little slow to kind of, get to a project that they wanted to test that core technology on. And when we said we're going to the data center, suddenly all the lights came on, and they said, oh, that's, fantastically exciting. And so it kind of sort of very quickly accelerated from there. So through the latter half of last year, we built that partnership out, did the deal at the beginning of December, and it's going fantastically well.
Amazing. And obviously Octopipe and ABB both at Datacloud this year as well, which is great to see. What would you say is unique about the partnership? Specifically, what it can unlock for data centers globally?
Of course, I mean, so ABB obviously is a global reference point, both in electrification, motors, drives, and so forth. They have so much of their equipment, sometimes very visibly within the data center. Sometimes actually people don't realise how embedded they are, sort of behind the scenes, as it were. So ABB has that relationship, has a lot of trust with the customer. The data center industry is a highly trust-based industry. We, of course, are a small, relatively unknown startup, and rightly people, want to know that who they work with, they can trust. So firstly, I think the combination of, ABB, the reputation, the trust they have with the customer, and then on the other hand, the kind of the innovation that we can bring, the deep expertise that we have in how we bring together sort of mechanical engineering, building science, physical AI modeling, and so forth, is something that is, unique, almost unique in the world, something that ABB don't have themselves. And so kind of bringing those two, parts together provides quite a unique offering to the customer. And so I guess sort of, perhaps for instance, some recent developments that we're working on where we are bringing some of the ABB technology and sort of integrating outputs of that into our systems to be able to offer, customers a more holistic not just efficiency optimization for the cooling, but something that's on top of that health aware, where we can better safeguard the equipment, and we can actually improve the lifetime value of the assets overall. And that's something that no single company at the moment can deliver effectively.
Great. And I think one thing maybe that I'd be remiss not to talk about at Datacloud this year in particular is agentic AI. Obviously, it's what everyone's talking about. Be really keen to get your perspective, though. Obviously, it's getting a lot of attention. Why has Octopipe chosen not to go down that road? And what does a non-agentic physical AI model actually look like in a live data center environment?
Well, firstly, the term agentic is something that's been, I think, a bit co-opted, perhaps largely for marketing purposes, to describe models undertaking autonomously or semi-autonomously tasks. So in fact, inside the product at Octopipe, we have multiple types of machine learning model. One type that we have, particularly around the optimization of the control policies, is something called reinforcement learning. We've, for many years talked about reinforcement learning agents. So in some sense, we have agents inside the product. The difference is that the agents that we have been building are explicitly designed with architectures that have been, optimized and are appropriate for modeling physical infrastructures, their topologies, and so forth. The large language model based agent model is not really an appropriate architecture for doing physical modeling and control response, in our humble opinion. However, it is very good for doing linguistic-based tasks, both human language and code. And so we do actually use language models within the product, but we use it as a linguistic layer to translate between what the lower level machine learning agents, reinforcement learning agents, for instance, are doing, and the human operator. Because a key part of the way that we think these systems should work is with a sort of a human either on or in the loop, with a lot of explainability, as much transparency as we can have, in order to really kind of build trust between the operator and the system. So large language models do have a role in our view, but where you see a lot of this kind of agentic AI trying to be applied to physical control systems, I think that's wholly inappropriate, and people should be very wary of it. And in general, in the market, I do think that there's a lot of people sort of throwing spaghetti at the wall and seeing what sticks, because of course what the LLM is very good at, and it perhaps is sort of playing on our kind of human emotions, because of the fact that what comes out of it is very convincing human language. We get very plausible looking results very quickly, and it's only when we really dig in that we find that there are kind of systemic issues with it. So I think at the moment we're in this phase of people just kind of throwing, it's easy to use, relatively speaking, that people are trying everything and anything with it. Most of it has no right being dealt with, by a transformer-based LLM. And maybe that's what's also driving some of the frothiness in the market, and maybe where we'll find some of that frothiness will, deflate when people figure out what use cases should really be solved with LLM-based agents and which ones should not. So it's not that we haven't gone down the agentic route, it's just that perhaps we have a very nuanced view of what an agent is, the types of models that you should use, and what they should be applied to.
Eric, thank you so much for taking the time to talk to us and sharing your insights. Really appreciate it.
Thank you very much for having me.